Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from ISI MStat 2018. The problem is on your screen. Consider the set of all functions from the set this to the set this, right? From 1 through m to 1 through n, where n is greater than n. If a function is if a function is chosen from this set at random, what is the probability that it will be strictly increasing? Now, it might seem at first that it is a probability problem. Well, it is a probability problem, but the actual thing about this problem is that it is a counting problem. It is a combinatorics problem. The probability application is very easy, the very simple. So first of all, we find out, let A be the set, the domain from 1 through m, and B be the codomain, 1 through m, where n is greater than m. Now, number of functions from A to B. How many functions are there? All possible functions without any restrictions, without any special features or anything. Just number of functions possible. This A can take any values, any n values, right? Again, 2 can also take any n values independently. So this is basically n times n up to where m times n. So it's n to the m, right? N to the power m. So these many functions are possible from this set A to the set B. This is the set of all functions, the number of functions that are possible. Now, how many strictly increasing functions are there? Number of strictly increasing functions. It has to satisfy this following inequality, right? Since 1 is less than 2 is less than 3 and so on is less than m, that if 1 is less than f of 2, if less than f of 3, and so on is less than f of m, right? F has to be such a function such that it satisfies this series of inequalities, right? Basically means that we have to choose the number of m permutations from this set B from the codomain such that they are in strictly increasing order. That right? We just have to choose the number of just have to say that how many m element permutations are possible from this set B such that they're in strictly increasing order. That's it. Now choose any m elements from B, any m elements. Suppose I1, I2 up to Im, where Ij is not equals to Ik. That means we have chosen distinct elements, m distinct elements from the codomain B, right? Now, how many ways are there to arrange them in a strictly increasing order? Number of ways to arrange the elements I1, I2 up to Im in strictly increasing order is actually one, right? Because they're distinct. You have to understand they're distinct, right? And so they can only be, you know, after arranging them in the increasing order, there's only one way to increase them in a strictly increasing order, just one way. For example, if you choose 5, 2, 3, 4, can only be arranged into 2, 3, 4, 5. There's only one way to arrange them in strictly increasing order, right? So that means if we choose any m distinct elements from B, there is only one arrangement of them in increasing order, right? So every selection, selection of m elements corresponds to a single permutation of the thing we are looking for. So number of ways to choose m elements from out of n elements is n choose m, right? From each of these n choose m possibilities, there corresponds exactly one such arrangement. So number of strictly increasing functions is also n choose m. You have to understand that. Number of ways to choose m elements out of n is n choose m. Right? For each of these possibilities, there corresponds exactly one arrangement of the elements in strictly increasing order, and hence exactly one function, exactly one strictly increasing function corresponds to each of these n choose m possibilities. Therefore, number of strictly increasing functions is also n choose m. Now we know the number of strictly increasing functions and we know the number of functions possible. So nothing, the probability of chosen function is strictly increasing is nothing but n choose m by n to the m. That's it. It's a very easy problem, right? So see you till then.